Hey guys, how's it going? So, if I was to be asked what was the hardest integral I ever had to solve, then without question, the square root of tangent x dx is the hardest integral I ever had to solve. I found this while I was browsing through the internet looking for tricky math problems. A lot of the times I can't really do ones that because I'm not a very creative guy. So it's like when you really have to flex your brain muscles, that's not my forte. But this one, I like, there was a voice inside my head that said, I should be able to solve this. And then after persistence, about 2 hours later, I was finally able to. 2 hours, guys. It usually takes at most a minute to solve an integral. So let's go about this. So I first tried doing the u substitution for tan x, but that didn't go very well. So I did the u substitution instead, for u is equal to the square root of tan x. Du is going to be equal to 1/2, using the power rule, tan x to the negative 1/2. Secant squared x. All right. But now this is good, but like we want to have the du in terms of like u terms. So what we will do is like say 1/2 to u, because u is the square root of tangent x. That's what we said. And then let's see, tan u to the power of 4 is tan squared x. So secant squared x is u to the power of 4 plus 1. Dx. That means that dx is equal to 2u, wait. Yeah, 2u over u to the power of 4 plus 1 du. Okay, let's erase this now. Not the whole thing, just this part. So let's go about this. Drawing this. This is equal to integral u, because square root of tan x is u, times 2u over u to the power of 4 plus 1 du. Which is 2u squared over u to the power of 4 plus 1 du. Now, after I was actually able to solve this integral, but before I go further, like I will say that after solving this about like an hour later, I looked at black pen, red pen. Apparently, black pen, red pen also did this integral, and he did not use partial fractions. I watched his solution, but I'm telling you, I was able to do it with partial fractions. So we're going to do it with partial fractions. It's a little trickier, but that was my intuitive step when I first approached this. So let's do it with partial fractions. So first of all, let's factor out u to the power of 4 plus 1. This is factorable. And we're going to say u to the power of 4 plus 1 is equal to 0. Now, why? Because we're going to do something, if you guys have forgotten, we're going to do something called the factor theorem. And in case you guys have forgotten what the factor theorem is, I'm just going to write it down here. The factor theorem, if x equals a, no, sorry, if f of a equals 0 for a function f of x, then x minus a is a factor of f of x. That was learned in pre-calculus 12. So anyways, we're going to go about factoring this, finding all four solutions. It does get a little ugly. You're going to have to use imaginary roots here and imaginary numbers. This could be cheating because imaginary numbers don't get introduced until either linear algebra or vector calculus. But at the same time, I think it's cheating to include a question square root of tangent x dx in calculus 2. Which, by the way, if your professor ever gives you a question like this, I think you could win a lawsuit of $26 million. True story. I've had experience, you know. Okay, so u to the power of 4 plus 1 is 0. Then the way we do it with roots is u to the power of 4 is equal to -1. And -1, so that's e to the power of I pi. There's going to be 4 solutions, by the way, from 0 to 2 pi. That's usually where all the roots are for something like this. E to the power of I pi. Wait, sorry, no. Let's do it like this. This technically isn't wrong, but I want to simplify it. So I pi, because e to the power of I pi is -1. But then every time you go 2 pi, you will also land back to -1, like e to the power of 3 pi I, 5 pi I, 7 pi I, so on and so forth. And then we can move pi out to the front. 1 plus 2k. It's worth noting that k is an integer. And now that implies that u sub k, because remember we're doing this, u to the power of 4 is equal to this. So when you take the fourth root on both sides, u sub k is equal to e to the power of I pi over 4 1 plus 2k. Where k is integer. Now, so there's 4 solutions. Let's just do k, 0, 1, 2, and 3. So u sub 0, when k is equal to 0, that's e to the power of I pi over 4. That's cos pi over 4 plus I sine pi over 4, 1 over root 2 plus 1 over root 2 I. U1 is equal to e to the I 3 pi over 4. that's cos 3 pi over 4 plus I sine 3 pi over 4, which is negative 1 over root 2 plus 1 over root 2 I. U2 is e to the I 5 pi over 4. Which in turn is equal to which in turn is equal to negative 1 over root 2 minus 1 over root 2I. And U3, the final solution, is e to the I 7 pi over 4. Which is equal to, let's see, cos 7 pi, 1 over root 2 minus 1 over root 2I. Okay, there we go. So we have these 4 solutions. Now, there's this trick I learned when I took complex variables last semester. That is like, you can take 2 roots. These 2 roots should be conjugates of each other. And then you multiply them out, and then you should, like, doing this will eliminate any imaginary numbers. So basically what I mean is doing something like this. So you 1 over so basically take 2 factors that are conjugates of each other and multiply them out, and you will eliminate all of the imaginary I components. So u minus 1 over root 2 minus 1 over root 2I we're taking this right now because remember, if x equals a is a factor of, no, if x equals a for f of a is 0, then x minus a is a factor of f of x. So we're using this. So u minus this value times, and then the conjugate of this is this. So that's u minus 1 over root 2 plus 1 over root 2I. And when you do that, that's equal to, wait, give me a sec. That would be equal to, okay, so let's just expand this out 3 times. It's going to get a little messy, but it'll be worth it in the end. So u squared minus 1 over root 2u plus 1 over root 2 ui minus 1 over root 2u plus 1 over 2 plus 1 over 2 minus 1 over root 2 I. Okay, wait, sorry. Something looks a little strange here. No, everything's good. Everything's on track. Okay, so 1 over root 2 ui plus 1 over root 2 plus 1 over 2i, sorry. Let's see, is that, okay, so that's negative, yeah, plus 1 over 2. And the imaginary parts should cancel out. So this cancels out with this, and this cancels out with this. So you're left with u squared minus 1 over, okay, so then this subtract together would be minus root 2u plus 1. Okay, that's the first one. And then let's multiply the last two factors. So that was the this and that. Yeah, these two are conjugates of each other. We already multiplied u0 and u3 together. Okay, so that would be u plus 1 over root 2 minus 1 over root 2i times u, let's see. I'm doing this the long way and expanding this out because I want to show you that the imaginary parts do indeed cancel out. Imaginary numbers are like magic in my definition. Plus, okay, 1 over root 2 plus 1 over root 2i. That's equal to u squared plus 1 over root 2u plus 1 over root 2 ui plus 1 over root 2u again let's see, plus 1 over root 2u plus 1 over 2 plus 1 over 2i okay, and then minus 1 over root 2 ui minus 1 over 2i let's see, plus 1 over 2. And that's equal to, let's see, the imaginary parts should once again cancel out, and they indeed do. That and that. Okay, so that's u squared plus root 2u plus 1. So these are the two factors we can break down into u to the power of 4 minus 1. And I'm actually going to show you that this can't be factored, that u squared, but plus or minus root 2u plus 1, these two expressions cannot be factored any further. And I'm going to prove that. Just take the discriminant of these expressions. So b squared minus 4ac That's equal to 2 minus 4 times 1, 4 times 1 times 1, which is -2, and that's less than 0. When you are solving by partial fractions, if the discriminant is less than 0, then it means it can't be factored any further. So let's just erase this part. Okay, so now, okay, so basically I have this written down. I'm gonna have to erase this stuff so I can go to the next step. I'm gonna give you guys 5 seconds, pause the screen and take note of all this down. Yeah. Okay, so hopefully you guys had enough time to take a look at it. I'm gonna erase this part now and we're gonna move on to the next step. Not the whole thing, but just I want to keep the question. I don't want to erase the question and my substitution because I'm going to need those later, but I'm going to erase everything else. I should have cut the video while I was erasing, but I just realized that now. Okay, let's keep this part too. So 2u squared over u to the power of 4 plus 1 is equal to au plus b over u squared minus root 2u plus 1 plus cu plus d. U squared plus root 2u plus 1. All right, so that's the thing. We're gonna find out what these coefficients A, B, C, and D are. So let's first multiply. I'm gonna write, because we're focusing on this right now. So I'm just gonna, we're focusing on this right now in our next step. Multiply both sides by u to the power of 4 plus 1. So that will give you 2u squared is equal to au plus b u squared plus root 2u plus 1 plus cu plus d. U squared minus root 2u plus 1. And let's expand this out. So that's this is equal to au cubed plus root 2au. Wait, let me think. Root 2au squared. Plus au plus bu squared. So before I continue on, it's worth noting that I know some of you might just be able to like go from part A to part C, like from do a single step and then do multiple things. I tend to avoid that because that's when you're most likely to make mistakes. So I like to simplify things a bit before I dumb it down. So AU plus BU squared. So that's why I prefer the slower method. BU squared, so I don't make mistakes. Squared plus root 2 BU plus B plus CU cubed plus, no, minus root 2 CU squared plus CU okay, plus DU squared minus root 2 DU plus D. And now we're gonna break these up into U cubed, U squared, U, and the constant coefficient. So 2U squared is equal to, we're using partial fractions strictly right now. So that's A plus C U cubed plus, let's see, for the U squared, root 2, okay, let's see, so plus root 2A plus B minus root 2C plus D U squared. Plus, okay, what about the A plus root 2B? A plus root 2B plus C minus root 2D. U, and then plus just two constant terms left, B plus D. Okay, let's compare these two parts together. So A plus C is going to be 0. Why did I don't even need brackets. Why did I do that? A plus C is 0. C equals negative A. B plus D is 0. So D is equal to negative B. Okay, let's focus on this term now. So A plus C, let's just do this the long way first. A plus root 2B plus C minus root 2D is 0. And A plus C is 0, where A is equal to negative C, as shown here. Root 2B. And remember, D is equal to negative B, so plus root 2B is going to be 0. And solving this gives you b is equal to 0. And because d is equal to negative b, b equals d equals 0. All right, now we have one more term to focus on, root 2a plus b minus root 2c plus d is 0. Okay, so b and d are both 0, so we can ignore that. Root 2a, no, not, sorry, it's not 0, sorry. That's going to be, we're comparing this u squared and u squared. That's equal to 2. Sorry about that, guys. Root 2a, yeah, because then a, b, and c and d would all be 0. That doesn't make sense yet. Root 2a, and then remember, c is negative a, so root 2a plus root 2a is 2 root 2a, which is 2. A is equal to 1 over root 2. And that implies that c is equal to negative 1 over root 2. Let me take a look at my solution to see if that was correct. Yeah, that's correct. So so now we can express these and fill in these coefficients. So that's equal to 1 over root 2u over u squared minus root 2u plus 1 and then minus 1 over root 2u over u squared plus root 2u plus 1. All right, so we have this. That's the expressed in partial fractions. Let's erase from here to here. I need to keep this part, but we can erase how we got A, B, C, and D. I have to be careful not to erase too much. All right, okay, good. So we know that this is the expressed function. Let's figure out the integral of each of these terms separately. So let's figure out what 1 over root 2u over u squared minus 2 root 2u plus 1 is. Du. All right, so first thing I'm gonna make a note, ln of this, ln of u squared minus root 2u plus 1. I don't have to include the absolute values since the discriminant is 0 and the leading coefficient is positive. U squared minus root 2u plus 1 will always be positive. So I'm just not including the absolute values brackets. Okay, so that's, I'm going to make a note that that is equal to 2u minus root 2. So because with this in mind, this is equal to 1 over 2 root 2, 2 root 2 with the integral of 2u minus root 2. I have to be a little careful here. Over u squared minus root 2u plus 1. Plus root 2 over u squared minus root 2u plus 1. du. Okay, so let's focus on one specific particular integral right now. Okay, so basically, let's focus on this part here. Root 2 over u squared minus root 2u plus 1 du. All right. I'm going to complete the square here on the bottom. It's likely we're going to be using the arctangent or tan inverse as the antiderivative. So here I'm going to say that that's equal to root 2 over 1/2 plus what would this be? 2, sorry, you know what, let's do this instead. U squared minus root 2u plus 1 over 2. Du. Okay, and then let's multiply the top and bottom by 2. So then that's equal to 2 root 2 over 1 plus, remember, we're multiplying the denominator by 2 as well as the numerator. So that's 2 times u minus 1 over root 2 squared. And our function here, it's evident that g of u, let's call this function g of u is equal to, remember this squared, the square root is root 2 u minus 1 over root 2. And the g prime u is just root 2. So we can use the arctangent formula for this one. Okay, so then that implies that the antiderivative or the integral is 2 tan inverse g of u. So root 2u minus 1. Yeah, that's true. Okay, so let's erase down this part here and say that this, okay, so that's equal to Okay, 1 over 2 root 2 ln u squared minus root 2u plus 1. If you guys are still watching, I don't really know why. I mean, this is going to be a really long video. Okay, plus 2 tan inverse. So 2 divided by 2 root 2, that's 1 over root 2. I'm just expanding out the 1 over 2 root 2. Okay, so multiply, yeah, that gives you 1 over root 2 tan inverse root 2u minus 1. Let me think. Is that right? Yeah, that's right. Okay, so let's erase this part. I'm getting a new I'm getting a writing pad on Friday. So don't worry, I'll be able to have a better platform sooner. Earliest Friday, but yeah. Okay, so that means that okay, let's solve the other one. So the what was that one? 1 over root 2u over, yeah. 1 over root 2u over we're evaluating this part right now, this integral. U squared plus 2 root u plus 1. No, plus root 2u plus 1. That's going to be equal to okay, so let's complete the square as usual, like we did last time. What did I do? Okay, so yeah, we're gonna express it a little like this for similar reasons as we did earlier with the first one, to complete the square so we get a ln and an arctangent. So 1 over 2 root 2 root 2, okay, so 2u plus root 2 over u squared plus 2 root u, no, sorry, root 2u plus 1 minus root 2 over u squared plus root 2u plus 1. du. All right, now let's just purely focus on this part in evaluating this, because I know the value of this integral is just ln of this. So let's focus on this part. Root 2 over u squared plus root 2u plus 1. Du. That's going to be equal to, okay, so let's complete the square on the denominator first. Over, that's 1 over 2 plus u, okay, wait, let me think. 1 over 2 plus u plus 1 over root 2 1 over root 2 squared du multiply both the numerator and denominator by 2. That's 2 root 2 over 1 plus 2 u plus 1 over root 2 squared. Okay, so du. And we're going to be use this value. I'm just going to say g of u is equal to, based on this part here, that's root 2 u plus 1 over root 2. So that is thus equal to 2 arctangent, or tan inverse, to tan inverse root 2u plus 1. Okay. Okay, so we have it right now. And then what do we do? Okay, we go about this. All right, so now we know the value of this integral, and that's 1 over 2 root 2 ln, we don't have to include the absolute value, you can if you want, u squared plus root 2u plus 1 minus 1 over root 2 tan inverse of root 2u plus 1. All right, so now we are practically done. Let me see. I'm just comparing my original answer to the to what I have. Yeah, okay, everything is in perfect order. So let's erase it, and now we can deliver our final punchline, or the final answer. This is going to be big, guys. After almost an hour, we finally have the answer. It was not worth it, in my opinion. Root tan x. So, okay, so the question, we write the question down. The square root of tan x dx is therefore equal to 1 over 2 root 2. And remember, we did it in the u substitution, so we have to put it back to the x. So ln tan x minus root 2 tan x plus 1 plus 1 over root 2 plus 1 over root 2 tan inverse root 2 tan x minus 1 Okay, minus 1 over 2 root 2 ln of tan x plus root 2 tan x plus 1 plus 1 over root 2 tan inverse root 2 tan x plus 1 plus 1 plus c. And that, it's so satisfying. This is the final answer. And I can, if you guys want, I can do a separate video where I take the derivative of all of this and get root tan x. I already did it myself last night, but yes, this is indeed the answer. I know Black Pen, Red Pen took the derivative of his own answer, and yes, he wrote in the thumbnail, it was ddx craziness is equal to root tan x. I'm gonna do the exact same thing, but anyways, this is so satisfying. Thank you guys very much for watching. I love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.